Any service industry tends to see periods of intense activity followed by periods of lull. Shift timings are adjusted to ensure that overlapping happens when resourcing requirements are maximum. We will see here how we can optimize shift manning while ensuring the right service levels. In the problem that we will discuss today, the requirement for every 2-hour slot is given for the entire 24-hour period. The objective is to man 5 shifts to ensure that adequate manning is available while minimizing the overall cost. The wages per person per day is given, and it depends on the shift timing. The variables that the solver will assign is the number of people per shift. Using that, we work out the people available per 2-hour slot. For example, between 12 noon to 2 p.m., people from all the 3 shifts are available, so supply is equal to S1 plus S2 plus S3. Once we have put the formulas of supply for all the relevant cells, we tie it to the requirement using the solver constraint that the number of people available must be greater than or equal to the people required. This is a linear programming problem, so we will also take out the sensitivity report. As the solution indicates, the manning across shifts varies significantly, with shift 1 being the highest. The sensitivity analysis of the variable cells tells us within which range of cost the solution would remain valid, but since all the shifts are manned, there is no value of reduced costs. For the constraints, the shadow prices indicate the change per unit of relaxation of the limiting constraints. In today's assignment, we will try out a variation of the same problem. We have 3 8-hour shifts and 1 10-hour general shift. The total operational hours are 20, but that is of academic interest. The minimum number of people to be deployed per shift is to be determined. To do that, we use an approach similar to the last problem. The variable cells are marked and used to arrive at the supply values against demand. The solver throws up the optimal manning and the resultant total cost. This was a simple case of resource allotment using linear programming. Do write to us if you have any problem that you would like us to model, and we would be happy to get in touch.